So the next example is a simple rational function. So a simple rational function, again, I have a polynomial divided by a simple polynomial, right? I've got the f of x is 5 times 3x squared minus 8 divided by x cubed. And I gave you the derivative, although you should be able to find it, but I gave it to you because it's simplifying. I wanted to get more to the how do you find critical values. Alright, so I've given you the derivative. The derivative is negative 5 times x squared minus 8 divided by x to the 4th. Now, before I get started, remember, critical values only exist in the domain, right? I can only have critical values in the domain. And so I'm going to find the domain of f of x. Well, the domain of f of x, everything works except 0, right? I cannot plug 0 in, right? X cannot equal 0. And so the domain, if I write in interval notation, would be negative infinity 0. There's a break at 0. 0 into infinity. And so there's an asymptote at 0, right? It does not exist at 0. Since it doesn't exist at 0, there's no derivatives at 0. And so you can't have any critical values at 0. Alright, so keep that in mind. 0 cannot be a critical value. Alright, now finding critical values. Well, you don't have to find the derivative. I've already given it to you. So you take the derivative, set it equal to 0, take the derivative, and figure out where it does not exist so long as it's a value in my domain. And that's kind of important in this case. Alright, so remember, it's a numerator-denominator kind of thing. I can only have zeros in the numerator, and the derivative does not exist if I've got zeros in the denominator. Alright, I'm going to talk about the denominator case first. Alright, if I look at my derivative, so my derivative is this part here, the denominator is x to the 4th. Well, x to the 4th is 0 when x is 0. But remember, x can't be 0. And so this does not apply. Right? There is no critical value at x equals 0. It does not exist in the original function. Right? It's not in the domain of the original function. It's not in the domain of the derivative. Since it's not in the domain of either, it can't be a critical value. Alright, so that does not exist case does not apply. The only place I can have a possible critical value now is in the numerator of my derivative. So I take my derivative and set the numerator equal to 0 and solve. Now, do you want to show setting equal to 0 because that's a critical step? First thing, divide out the negative 5, which again, if you hadn't written the negative 5 down, would have been fine because 0 divided by anything is 0. So if you kind of skipped the first step and gone to the second step, would have been fine. And then move the 8 over. And so I get 8 equals x squared. Use the square root property. Remember, plus or minus. And so I'm perfectly fine. I actually prefer if you leave it square root of 8, negative square root of 8. But I know that students have had teachers in the past that like them simplified. And so I would accept either one. I actually prefer the square root of 8 because I think it's easier to use. So that's a personal preference. But if you wanted to rewrite it, it's 2 root 2, negative 2 root 2. Either one of those are acceptable. They're the exact same critical values. So again, I prefer the root 8, so that's the one I'm going to use. But if you like to, if you're one where you've just gotten used to always reducing those, always reduce it to 2 root 2. Again, either one is fine. Alright, so the critical points. Again, I'm not going to graph this one. I'm just going to find my critical points because I was really just looking at the algebra. The point part, well, the y comes from the original function, f of x, which the original function was 5 times 3x squared minus 8 all over x cubed. And so square root of 8, f of square root of 8, negative square root of 8, f of negative square root of 8 is where you'd find your critical values. Right, which again, you'd take your square root of 8 and plug it in. I'll leave that for you to do. Again, I would, assuming you can plug them into a function and go from there. I was more focusing in on the algebra. Alright, so these would be where your critical points are located. Alright, we'll stop there. We'll pick up the next example in the next video.